Alright class, welcome to warm-up 2.2. Today we're going to take a look at some warm-ups from last night's homework. So we're working here in example 1 on simplifying your expression. Remember that when you have no sign or a positive sign outside the brackets, you simply drop the brackets. But if you have a negative sign, like right here, you need to remember to change all the signs inside when you remove the brackets. Then in the last line, it's all about collecting like terms. In the second example, it's basically the same. You've got to remember integer laws, and you've got to remember your rules with the distributive law. So out front of the first binomial here, it's a positive sign, so you can simply drop the brackets, whereas in the second one here, it is a negative sign, so you change the signs. And remember your integer laws, that a negative times a negative becomes a positive. And this one might be tricky because a negative times a negative becomes a positive. Then you're multiplying it by the negative out front, which makes it a negative. Once you've removed your brackets, you can then go to collect like terms, and when you try to collect like terms in this case, you've got to get a lowest common denominator in order to simplify each term for the final example. Taking a look at question 2, ladies and gentlemen, we need to determine whether each pair of functions is equivalent. So for A, looking at the complexity of each function, we are going to just sub in a value. So we're just going to arbitrarily pick x equals 1, sub it into each function. So we sub it into f at 1, and the solution becomes negative 24. Whereas if you sub it into g at 1, the solution becomes 7. So this way we can state that f at 1 does not equal g at 1, and if they do not equal, therefore the functions are not equivalent. Okay? In example 2, this is a more simplified question where you can simply expand each equation to see if they're equivalent. So looking at y1, again we use a shortcut, square the first, double the product, square the last, and then we understand that taking a look at the second one, we do the same thing, square the first, double the product, square the last, and we realize when we simplify through that in this case y1 does equal y2, so therefore these functions are in fact equivalent. Okay? That's our warm-ups. That's what you should have learned from yesterday. If you have some troubles from that, please come see me. Now on to today's lesson. Today we're taking a look at multiplying polynomials. This is mostly a review from grade 10. So for the first example, we're going to be using distributive law and FOIL. The short form for FOIL is first, outside, inside, last. And we use that when we multiply two binomials, like in the example B here. Okay, let's skip up to example A. However, when you have one term outside of the brackets, you multiply it by every term inside the brackets and look to collect like terms where possible. In example B, we've got a binomial times a binomial, and we're using FOIL, first, outside, inside, last. Each of these arrows represents a multiplication, and then you look to collect like terms. In C, it's a binomial times a trinomial, which means you take every term that's in front in the binomial and you multiply it by every term in the trinomial. So in this example, you're going to have 6 factors once you're done your multiplying, and then you go to collect like terms. All right, example D, ladies and gentlemen. There are 2 ways to show this. Method 1 is if you expand out the squaring of the binomial and then you FOIL it. Let's take a look at that. So again, you rewrite the base in this case is 2x plus 3, and you write it out twice because the exponent is to the power of 2. Then you use FOIL, first, outside, inside, last, and then you collect like terms. The second example, and if you're planning to go to for you functions, you're going to want to adapt this short form. And the short form is square the first, so 2x squared is 4x, 2x squared is 4x. Okay, double the product, which means 2 times 2x times 3 gives you 12x. And you'll see that on the side here where I write that little bit down. And then square the last. So 3 squared is 9. Taking a look at example E, we notice that we're using distributive law in both our expressions in this equation. Okay, so we start off by multiplying the first one, multiplying the second one. That helps us to remove the brackets. Then we collect like terms. Just remember, guys, that BEDMAS is playing a role in this. So you multiply before you add and subtract. Last question F. Sorry, not last question F, but question F. We take a look at a binomial times a binomial, and out in front we have a monomial. So this is 3 terms. I like to deal with the multiplying the binomials first, and then I will use distributive law after. So we put the 4 down, leave it out front, and then we're going to use first, outside, inside, last. Collect like terms in the second line, and then in the third line here, we will use our distributive law and multiply every term by 4. Okay, so here we have our simplified answer. In G, ladies and gentlemen, again, you're multiplying a binomial, but in this case, is to the exponent of 3. So again, x minus 2 is times itself 3 times. This is a tricky one, and this may be new. This is probably a little step up from grade 10, so welcome to grade 11 here when we do this. Again, we're going to separate or isolate 2 of the binomials where you see these brackets, and we're going to do first outside, inside, last. And then we're going to realize after we collect like terms that right here we've got a binomial times a trinomial. So every term in the first bracket gets multiplied by every term in the last bracket. And then we go to collect like terms. Here ends our lesson for 2.2. The homework today is page 95, numbers 1 to 4, 6, 9 to 11. Again, see me in class if you have any troubles with this lesson. Have a great day today.